Everyone, I'm Raswana Pavleen, Assistant Professor of Department of Mathematics from St.Josephs College. Today we're going to see about the Gauss-Jacobian method. Consider a system of simultaneous equation or a system of equation over like this. We assume the coefficient matrix of this system is a diagonal dominate. The system is a diagonal system. The above system can be written as like I need to have only the x1 value. So I'm gonna substitute the values over here. So I'll get like this c1 minus a12 x2 minus a13 x3 up to the n terms divided by 1 by a1. I'm gonna find I can even find x2 values and even I can find x3 value up to n terms. Depends upon the type of simultaneous equation. If it is of 3 cross 3 system of equation or 3 cross 3 matrix or 4 cross 4 matrix or 2 cross 2 matrix. We start the initial value for the variable x1 x2 up to xn to be of x no x1 naught, x2 naught, x3 naught up to xn naughts. Using the values in the equation 1, 2 up to n terms, respectively, we get the values. By putting the values respectively, we get the next approximation. In general, if values of x1, x2, and x3 in the the alternatives are given by like given, you can get the values. I'm gonna repeat this process up to n terms. Like you need to have the iteration we're gonna apply this iteration until I get the iteration which is if I'm doing up to ninth iteration, I need to have ninth iteration and 10th iteration to be the same. So let us try to solve an example over here using Jacobian iteration method. They are given a simultaneous equation and coefficient matrix of the given set of equation can be given as a matrix A. That I want to have only the A matrix. We know that A is not a diagonal dominant. Also A which is not which is not a diagonal matrix. So I'm going to interchange row 1 with row 3, row 1 with row 3. So I'll get an almost a diagonal matrix which is over here. So and then I have given in this previous video, you can refer even that. Using that, I'll get the values of x. Like I'm going to have the x value, y value, and z value. If I substitute for x, y, and z is equal to 0, I'll get the x value. That is 7.74 divides 10 equal to x value. If I using calculator, if I solve that, I'll get the x1 value as 0.7114. So now I'm having an x value, but I don't know z value. So I'm going to apply in the equation 2, like I'm having z value, x value as 0.744 in whereas over Jacobian, you're gonna apply for x naught, y naught, and z naught equal to 0. So I'm gonna have as x values are 0 and y values are 0. So I'll get the result as this like this, and I'm gonna repeat this process: x value as 0 and y values as 0. I'll get the result. So I'm getting the iteration values. Here I'm having x, y, and z value. So using that, I can get x2, y2, and z2 value. 1 by 10 into with 7.74 y1 minus y1 value is over here, right? And z1 value is over here. So I'm applying the values over here. I'll get the result as 1.1742. That is and the y2 value over here can be obtained by the values of x and z. So I'll get 2.3272, and z2 values can be obtained by using x and y. That is nothing but 2.6172. I'm continuing this process up to the iteration of seventh iteration. After the seventh iteration, the difference in sixth, and the seventh iteration are negligible. Hence, the solution of system of equation can be given as x is equal to 1.075 and y is equal to 2.524 and z is equal to 2.765. Why? Because over here you can see the sixth iteration values and seventh iteration values are almost same. 1.0783 over here and 1.07. I'm having the same 3-digit number. Having 3 decimal values are same and your y value 2.52, 2.52, 2.76, 2.76. So I'm going to stop over the 7th iteration. I'll get the result. Thank you everyone for listening. I hope you understand.